Welcome back to Ox Tools. I'm Tom, and you see that I'm sporting my versatile machine repair shirt. This was sent to me by my buddy Cliff Fender. He sent me a hat too. Nice green hat. I love the green on this, Cliff. These are great. I can always use t-shirts around the shop. And these are the fancy pants ones here with the collar. So he sent me a couple of things. Cliff and I talk on email a bit, and he has a versatile machine is in Wayland, Michigan. And he goes out all over the state and repairs, rebuilds machines, and does all that kind of work. They're working on a, I don't know, 200 horsepower Blanchard grinder right now or something like that, he was telling me. Anyway, pretty cool stuff. So, we got a Meatloaf episode here, and we're going to bounce around the shop a little bit. Got a lot of little things going on, and kind of updates on some projects. We're going to look at the we're going to look at a bunch of stuff. So instead of me talking, let's go look at some stuff, because there's plenty of talking after this. Let's go look. Hey guys. So I came out in the shop this afternoon, and wasn't sure what I was going to film. So I just started cleaning up in the shop and kind of resetting things and getting things kind of back on an even keel here. Kind of replenish and reset. And it's one of my things that I do when, you know, maybe you're not in the mood and you're not sure what project you're going to work on. And so I just start cleaning up. And it kind of gets the juices flowing out in the shop, and you get warmed up, so to speak. It's kind of like a warm-up or a ritual, you know, like putting your apron on and sharpening your knives and your tools and whatnot. Some of you guys are probably wondering what I'm doing here, but this is one of these Typhoon blowguns here, and I have several lengths of nozzles for these things. And when I'm using the air broom to reach in behind the machine, I use the longer one so I don't get my face down in there. And then on the machines, I use this nice short one here. And they have these up to, I don't know, 3 feet or 4 feet, something like that, over a meter. And so I don't generally keep that one on. So let's cruise around the shop. And you can look at some of the things I'm kind of cleaning up here. And there are future projects, and you know about some of them. So let's go look. So the whole WD, you start in one place and you end up going over there, and you go over there, and you go over there. And the whole WD-40 thing was, I was cleaning this super spacer up here and getting it ready to reassemble, and I got a little bit of news on that. So I grabbed the WD-40, and some bozo kind of used the last of it here and didn't refill it. But I got nobody to blame but myself. But fortunately, I know how to do it. So, and these new, if you guys haven't experienced these new spray bottles, you don't have to take the dip tube out to fill them. And so here's the example. You take the dip tube out, now this thing's dripping WD-40. What do you do with it? You have to set it on the bench, right? And then fill and put the thing back in there and maybe contaminate it with crud that's on the bench. But these new ones here, child-proof, I guess. You can fill them without taking the dip tube out, and it's kind of nice. They don't hold as much, but that's okay. I don't mind. So the whole story, what I needed the WD-40 for was I'm cleaning some of these fasteners on this that were all weasel snotted up. And let's see if I got a good example here. You can see some of the ooky crud that was on there on this thing. So anyway, I'm working on cleaning those up. So and we'll go take a look at them in a minute, is I just drew up some masking plates for this. And that's the intermediate plates that go on here that mask off most of the holes and just leave 2, 4, 6, 8, 10, 12, 16, 18, whatever increments you want, so that you don't have to count divisions. So these normally come with masking plates. They get separated from the unit and then they get lost and thrown away or whatever, and they're kind of expensive to buy. So what I did was I measured them, I measured it, and drew it up, and I'm having them laser cut. So, but we'll go look at the drawing on that. So anyway, this is going back together. I'm sick of looking at it, so I decided to finish it up and put it back together. So let's go look at something else. Okay, so let's take a look at the those masking plates. And I did this in AutoCAD. So let's see, we'll look at the DXF first. So there's the ones I asked for. So I sent a DXF to my laser cutting guy here locally, Seaport Stainless, and Ryan has always helped me out with this kind of stuff. So I'm asking for one each of these masking plates in 1/8 stainless steel. Now, what I do on the DXF here is I just throw a couple of dimensions on it. That way, if there's inadvertently any scaling errors or whatnot, then he picks up on it, so he measures it when he pulls it into his system and takes a look at these holes, for example, and just verifies that they're the size that they're supposed to be. Okay, I've seen people get into trouble with scaling problems, you know, when exporting DXF sometimes. So this is a shade over 3 3/4. So it fits on easily. These are not super precise, although they actually will be in this case, just by the nature of how they cut them out. The challenge here was actually measuring the angle on that, because it's kind of it's not an odd angle, but the length of this tooth here is very short on the sample that I have, and so getting a reasonably accurate angle was kind of difficult. So so let's see, zoom extents. All right, so I'm going to get 8 of these things. Okay, 3, 4, 6, 8, 10, 12. 2 and 16, I think, is what this last one is. You know, I just said, well, let's round off here, and now this one's, you know, arguably kind of useless because it's every other index. This one just keeps you out of trouble if you got a 180 index that you need to do, so you don't accidentally index one tooth off. And then this little hole here, just for your viewing pleasure, this little hole here is actually it's a locating pin that locates on the master plate, and so that it clocks it with the teeth on the master plate. Okay, so that's what that's about. Let's close this, and no, I don't want to save it. We're going to open up what I call the seed drawing here. And that's this here. Okay, so it's one tooth and the hole and the OD. Let's see, what do I want to say here? I don't know. So just quickly, here's how you how I created them. And so if let's say I want one of these that has 7 teeth. Okay, that won't work, but let's just do it as an example. So what we're going to do is we're going to array this, the thing that we want to array, okay? And so I've selected the object, and then I'm going to use a polar array here, okay? And then it's asking me what the center point is, which I'm going to grab here, and you see the little purple circle there, so I'm going to say yes, that's it. And then total number of items, let's just say 7, okay? And there we go, beep, okay? Now you notice that it doesn't have a gap like the others. So what I need to do there is I just go back and I can trim that out of there, okay? Oops. So I can just trim that little bit out of there, okay, and do that. Now 7 won't work because it's not a factor of, let's see, how many are in there? 24. There's 24 teeth on the master. So now I can just kind of back up here and just kind of eliminate all that stuff. I don't know, what else? I think that's about it. It was kind of interesting measuring that angle, and actually, you know what, that's probably worth showing you guys. So I'll drag that master plate out and we'll take a look at it. So zoom extents, let's save that. All right, let's get out of here. You guys like my screensaver there? This is an old, I think this is the Philadelphia Navy Yard here. This is a Shorpy picture that just is just fascinating. If you, I could stare at this thing for hours just looking at all this stuff. Pretty cool. American flag up there, belt drive machines, big guns. What's not to like, right? Okay. Okay, so here's this master plate out of the Yuasa Super Spacer, and you can see here they're kind of like gear teeth, all right, but they're flat-sided, so they're not involute, so they're flat-sided. Now, so the job was to measure that tooth angle, the included angle of those, okay, and you know we wanted to do it. It's going to be, you know, my belief was that it's going to be some, you know, humanoid number, right? It's not going to be some oddball thing. But we're on a circle, so that makes, you know, doing something like this kind of tricky. Although that's not a bad way to do that, is it? So, but what we're doing is, you know, we're subject to a little bit of interpretation and sighting along that, right? And it's not that easy, right? Okay. So, you know, basically I'm rocking around here. I've got a chamfer to deal with and all that. The cool way to do this is on an optical comparator where you just project and then you can actually line up on a tooth and measure it accurately. Actually, this is not. Yeah, we'll see. I'm getting a funny number. Here. So anyway, I tried. I have one of these, so I was fiddling around with this. This guy here with the acute angle attachment, and this is a tool I got from one of my old mentors, Fred Van Beber. There's his name right there. He was real good about engraving his name and everything. So the way this little attachment works, let's see, let's go this way here. That index is there, and then it locks, and now you can have an acute angle situation. Okay. So, but you gotta sit there and fart around with it and get lined up on stuff. And once again, it's subject to interpretation because you're sighting. You can't actually grab those surfaces, right? Because there's not enough to grab there. So this is a kind of a challenging measuring job. And angles are where you get into real trouble measuring them. Okay, and as you guys may well know. So what I ended up doing is I used some pins, and I used a couple sets of pins. And these are just 3/8 here, roughly 10 millimeter pins. And fortunately, the number of teeth here is even, so I have some that are directly opposing here, okay, like so. And what I did was I found a pin that touched the sides but did not touch the bottom, and it's not this one, it was some others, and got very close to the bottom, as close as I could. And then I found a pin that was only 1 mil away from that, and I put it in the other side. And then I could measure over the pins, okay? And this is kind of a classic way to measure this kind of stuff. And I used a micrometer to get the best measurement I could. So it was easy to measure the OD, okay? I can measure the OD and I can measure the root pretty easily, okay, without too much difficulty with a micrometer, okay. And then, so I could create those circles in my AutoCAD layout. Then I needed to create the lines that are the angled gullets here. These are the teeth, these are the gullets, okay. So by using two sets of pins and careful measuring, I determined that the angle was 20 degrees, okay. And like I said, I didn't, when I constructed all this on the computer, it wasn't exactly 20 degrees. It was very close. It was 19.8 something or whatever, right? I'm fairly confident that it's 20 degrees, okay? So, you know, there's measurement errors, and then there's cumulative stack-ups here, and then, you know, when you're using pins, so maybe you have a 375 in one side and you have a 374 in the other side. It's only 1/1000ths, but that changes that whole measurement. It's shifting it around on this circle. So now, fortunately, these masking plates don't have to be, they're not dead nuts accurate. So they just basically block off, you know, these holes here and allow you to drop into these, but not interfere. So the masking plate actually sits kind of like that and leaves that opening so the pin can drop in there, but it won't let you drop into there. Anyway, that's how it works, and that's how I measured it. So that was probably worth talking about. Okay, so we get, this is the horrible fright saw that I showed you a week or so ago, and there I have it's a Norton Gemini cutting disc, and it's got a 10 millimeter hole, and it's about a little less than a millimeter thick, so 0.35 inches. And so I replaced, let's see, do I have it over here? And I have the saw blade. It comes with a tooth saw blade, but the one at work we use with an abrasive blade, and it works real good. So let's replace the safety guard here, okay? And it's got this dorky lock here. I don't know, I'm thinking about clipping that off. It's bugging me already. Anyway, let's give it a try. And you can see that, I don't know if you can see that, it's a little piece of brass tubing that I cut off. So this is some thin wall brass tubing like guys like us might want to cut for something. And I'll grab a piece of stainless too. We'll try some stainless, see how it works. It's not too loud, huh? So this thing has a little V-groove in it here, so we'll just slip this in the little V-groove, which is kind of nice. Now you can see this jaw's, I hope you can see that. Am I in the scene there? Yeah, you can probably see that. The jaw wants to tilt up, but I don't think it matters for this here. See, okay, that's bugging me. You know what? Sorry, you're getting castrated. All right. Hey, that's better. Okay, so let's see, I don't want to cut off that much. I'll cut off that little. All right, let's try that. All right. Now, it's not a total burr-free cut, but it's pretty good. But it doesn't put a lot of pressure on the tubing. So let me grab a piece of stainless. Let's try it on a piece of stainless a little heavier. I'll switch the camera off for a sec. Okay, so here's some stainless tubing. It's 5/16, about 8 millimeter diameter with a 1 millimeter wall, about 40 thousandths wall by the scale. Slice this off here. Let's see how it behaves on this. I haven't tried it on anything this big. We usually cut itty bitty stuff with ours, so. that's it's a little saw, right? We weren't expecting miracles on that. I'm just looking at the end. I would say that's not super straight, and maybe because I was pushing pretty hard, the blade might have been curving off. And for those guys that know this already, let me. So we got, this is a little dressing stick that I've had for years. It's busted, been dropped a bunch of times. And you can dress the wheel. It makes it nice and square again and opens the abrasive up. You can also use something like this. This is Norbide, or Norbide. And this is a boron nitride, super hard monkey's uncle, to kind of square the wheel up and keep it free cutting. They are abrasive, so they do kind of load up. So let's try this again, see how it behaves. I'll go find something else. Maybe we'll get a little piece of tungsten to cut off. Anyway, that one looks pretty good. I'm rotating it and looking at that edge as I rotate it, and I don't see it wobbling around like this one is. That one's wonking around there a little bit. So stainless steel, yeah, I don't know. Small stuff, yeah, fine. It's a $30 saw. You're not going to go too wrong there. Anyway, little update on that. And these little discs, these are a dollar piece from McMaster Car. So anyway, update. Okay, this next one here comes to us from my buddy Chuck back in Michigan, and he made a little cool little wood crate and sent this to me. I think the story is that he picked this up with a lot of tools that he bought somewhere, and anyway, he didn't see himself using this, and so he decided to bequeath this to me. So this is actually pretty cool. It's basically it's a very accurate bench micrometer, and it's made by, let's see if you guys can see that there, the Bochler Instrument, Tucson, Arizona. So from Tucson to Michigan to California. So this thing's been around. Now it's got a large barrel on it, and it's a metric micrometer. Okay, so let's see here. And I kind of adjusted it a little bit and got the index kind of back where it belongs here. Now it doesn't have a ratchet thimble on it or anything like that. Oh yeah, me and my big mouth there. Oh, you know what? I loosened that up. Let's back this up here. So it's got an anvil that you can pull out and kind of set this thing. All right, we're coming up here. Let's kind of snug that down a little bit. So this thing will read let's lock that, okay. All right, so this thing has a vernier to a half a micron, okay. So that's a 5/10,000ths of a millimeter, all right. So that's a pretty small increment. So there's 10 microns between there, so those are 2 micron divisions, and then it has a vernier that I can read. Let's get a proper pointer there, Mr. Wizard. It has a vernier that I can read it down to a half a micron. Now it doesn't have a clutch or anything like that, so this is subject to some operator feel here, and it has a I think it's a 25 millimeter range. Let's see, something like that. Anyway, it's quite smooth and quite nice. And yeah, 20, I'm not going to run it out all the way, 25 millimeter range. Carbide tip. I kind of think this isn't the original anvil on this side, and I'll show you why. Let's run the, actually, you know what? I'll let putzing around. So you can see that this is marked. This looks more like a gauge pin to me. In fact, you know what? I forgot I was going to do that. Let's measure that. Okay. So, we just want a quick measurement there. 965. Yeah. So this is a gauge pin that somebody put in there. And if you look at the end here, the end isn't lapped, and then this end is marked. So those really aren't proper measuring surfaces. So somebody found a pin that worked and stuck it in there, and you know, probably work okay, but you're not going to measure to a half a micron measuring against a surface like that. It was probably carbide tip like that as well. So I now have a 9.660 millimeter gauge pin, and the other side I have a micrometer. So maybe we can make a pin that has a lapped anvil on the other side there. So Chuck, hey, thanks a lot. This is pretty cool. It's a nice little little device, and you know, this is used to check items on the bench. You know, where you're doing inspection or whatever within this range. And that way you don't have to handle and manipulate the micrometer by hand. You put the object in there. And this would be for smaller objects, things, I don't know, things like small things that are, it's easier to hold the part than it is to hold the micrometer. And this just gives you more consistent measurements on, in the laboratory if you're not hanging onto the thing. Anyway, Chuck, thanks a lot. That's pretty cool. Okay, so this cruising around the shop, this was sitting here, and I forgot that it was sitting here. This comes to us from my buddy Tom Bellus, okay, and he's in Arkansas, and he was in a pawn shop, and he found this little gauge here, and it's marked Harry W. Dietert, Detroit, Michigan. Let's see, maybe you guys can get a look at that. Okay, and it says mold strength PSI. So what it looks like to me, examining it here, looking at this foot, is it looks like it measures plastic or rubber hardnesses also. So it's probably indented a certain amount, and it gives some kind of relative reading that was useful to them for whatever it was. Now we don't know how far they pushed it, and it probably had something else around it. I'm not sure. Hard to tell. But what leads me to believe that is the scale on this isn't continuous. Okay, and looking at the foot here, let's look at this real close. It's precision ground. It's very flat, and it looks like it's set up to have a particular area. Let's see, maybe I should measure it. You know what? It doesn't really matter. It's some fraction of a square inch, and anyway, it's got a pretty good spring inside it, so it doesn't operate like a normal dial indicator. So I'm pushing up against the spring. Let's see. Let's get a max hand. Yeah, maybe, yeah, I don't know. Maybe it's supposed to bottom against it, I don't know. Anyway, it looks like this is an old Federal indicator that was made special for this Harry Dietert company. Anyway, Tom, thank you very much for sending that in. It's kind of a cool piece. Looks good. And he put a little piece of rubber tube on there. He found this at a pawn shop and thought of me, so he picked it up and sent it into the show. So thanks, guys. Okay, so actually we got a bunch of interesting stuff over here. Let's do this one first. This is a big fat box of inserts here, And this comes to us from a viewer and his son. The viewer, his name is Tom Stark, and his son's name is Josh. And it also happens to be Josh's birthday, actually, pretty recently. So happy birthday, Josh. And there's a present on its way to you, and let me know when you get it. Anyway, Tom sent in, he says he's been tripping over this box in the shop for years, and he finally decided to do something with it, which was send it to me. And I'm not going to go through all of this. There's too much to go through. A lot of this is really, really old stuff, but there is some really good stuff in here. And here's an example. This is a little threading insert. Actually, it's a big threading insert. 3 edges on it. I happen to have a couple holders that use this particular one, and I like it for threading. So, and then there's some other CCMTs in here that I can use, and a few other little things. And anyway, so there's some neat stuff in here. Now, there's some really weird stuff in here too. So let's take a look at one of those. This is an old Valinite here, and these appear to be some kind of little radius bit for doing corner radii. So this actually might be a good project to make a little holder that holds those, because these have a precision ground little radius in it and 4 corners. So it'd be pretty easy to make a holder for that. So there's a few of those in there. There's another pack of those. And then there's some little ones that have a little corner radius on it too. So, like I said, I'm not going to go through all this. Let's move this out of the way. Tom, thank you very much. That's cool. There's some good stuff in there. Let's move that aside. But actually, Tom works for or owns Steel Services, Inc. I'm not sure which. He wasn't specific about it. And he sent me some little data books here, which is kind of cool. So I'll pass some of these along as I mail packages out. So thank you. Those are always cool. And then there were some little notes, little scratch pads that the steel guys give you. And my wife already hooked onto those and took them off into her little area. She likes those. This is one of the more interesting things here. This was in this box of inserts here. And this is actually a little holder, and it's an oddball little holder. It's a little cartridge, but it has a diamond in it. Okay, so this is a diamond turning tool here, and I'll bring you in close so you guys can see this thing. So it's a little triangular insert, and one corner of it has a polycrystalline diamond in it. So it's probably a cartridge. It looks like there are some clamp marks on this. Maybe it was clamped into another holder or something like that for some high-speed or hard machining, something like that. So we'll take a look at that. So I'll bring you in close and we'll take a quick look at that guy. Okay, so there you can see it. That little dark corner there. That's the diamond. And maybe if we have some hard turning to do, we might try that. And like I said, you can see there's looks like a mark where it was clamped into some other kind of a holder. Maybe a face mill that had a bunch of these in it, or a cartridge that went into a lathe or something, I don't know. Anyway, Tom, thank you very much. It's pretty cool. And now I have a little diamond tool that we can try on some real hard stuff. Okay, so this next one here, little tag there. This comes to us from Lucas Sahlstrom, and he's up in British Columbia. And so, as you can see, it's kind of a hammer. It's a special hammer. We're gonna pop that out. I think they call it, what do they call it? A classic Friday night hammer. So what it is it's a bottle opener, but it's a hammer too, which is kind of cool. So this will go into my my hammer collection. I actually haven't tried it yet. I don't have any bottles handy around here. Lucas, thank you very much. That's a cool gift, and right up my alley. So thank you, my friend. That's a fun one. So bottle opener hammer. Cool. Thanks.